Now in this video we are going to do some questions on relative motion or relative velocity. Right? The question, see this question. The question says car A has acceleration of 2 meter per second square due east, and car B has acceleration of 4 meter per second square due north. Right? Let's take a coordinate system. You always draw a coordinate system. In any physics problem, you must draw the coordinate system first. So we are finding that car A has got a acceleration in east direction, 2 meter per second square. Yeah, this is east. This is east. You see, this is east, west, north and south. And car B, say this is car B, it has got an acceleration in north direction, 4 meter per second square. So you have to find acceleration of B with respect to A, or relative acceleration of B with respect to A. See, acceleration of B with respect to A is same as acceleration of P in a frame attached to A. So it's a relative acceleration. Acceleration of B with respect to A is, as you have done for relative velocity, you will do similar thing for acceleration also. AB minus AA. So AB is we'll write in vector form 4j minus 2I cap. Alright, 4j minus 2I cap. That's the acceleration, which is converted as 2I cap plus 4j cap. So what is this direction? Negative on x side and positive on y side. So it will be moving in this direction. That will be relative direction of relative velocity. Acceleration of B with respect to A will be in this direction. You can put it in this form also. The magnitude of this vector is how much? 16 plus 4 root 20. Yes, and root 20 is what? 2 root 5 plus, so that's the unit vector. That's the unit vector, and the magnitude is root 20, which is 2 root 5 meter per second square. That's unit vector. You take out the magnitude from the vector, what remains is unit vector. This is the magnitude, so you take out the magnitude, what remains is unit vector. This is unit vector. That is telling you this direction, the unit vector in this direction, n cap, and the magnitude is 2 root 5. 2 root 5. Getting a point? Okay, let's move to next question. See this question. Car A and car B starts moving simultaneously in the same direction along the line joining them. Okay. Car A with a constant acceleration A equals to 4 meter per second square, while car B is moving with constant acceleration of V equals to 1 meter per second, right? 1 meter per second. So car B is moving with constant velocity, whereas car A is moving with 4 meter per second square. At time t equal to 0 second, car A is 10 meter behind car B. Find the time when car A overtakes car B. Okay. So car A starts with 0 velocity, starts moving, they start with rest. Car A and car B starts moving, means they start from rest. So one is having velocity 1 meter per second, other starts from rest but has an acceleration of 4 meter per second. Okay, let's take this. Suppose car A lies here at the origin, and say car B is here. This distance was how much? This distance is 10 meter. So car A is moving with acceleration 4 meter per second square, and initial velocity I'll assume it to be 0 since it start moving. The initial velocity is 0. So what is the velocity of A? The velocity of A is, both are moving in x direction, so velocity of A is how much? 0 plus u plus at, you know, v is u plus at, and this velocity is vb is how much? Vb is 1 meter per second. Okay, vb is 1 meter per second. So the relative velocity of A with respect to B is how much? There is a velocity of A minus velocity of B. That is velocity of A in a frame attached to B. Velocity of A in a frame attached to B. So VA is 40 minus 1 meter per second, and the distance initially was 10 meter between them, and finally we want distance to be 0, right? We want to find time taken so that the distance become 0, right? So okay, so this is the relative velocity. This is the relative velocity of A with respect to B at time t. This is the relative velocity of A with respect to B at time t. If I take a frame attached to B, if suppose this is S frame and this is S dash frame, this is S dash frame. So if I take a frame attached to B, right? So in this frame, the velocity of A is going to be this at time t, and I want that in S dash frame we want the time taken by A to travel a distance of 10 meter. See, that is same as saying this S dash. Let's take a S dash frame which is moving with respect to S dash frame which is attached to B. Let's take a S dash frame which is attached to B. So S dash itself moves with 1 meter per second. So in S dash frame I want the time taken by this A to travel distance of 10 meter. That's the way we can say. So the velocity of A in S dash frame, that's the relative velocity. Relative velocity means this only. Relative velocity of A with respect to B is velocity of A in a frame attached to B. So velocity of A in a frame attached to B is S dash, and I want that when A comes to B, that means it covers a distance of 10 meter in this frame S dash. So velocity of A in S dash frame is 40 minus 1, right? B is located at the origin, A is located at the origin of S dash frame, A is at a distance of 10 meters. So I want that A should come to B, so that means it must travel a distance of 10 meter with this velocity. So I can say 40 minus 1 dt. See, you know, V is dx by dt. I am working in S dash frame, so dx will be v dt integral. So that should be equal to what? 10, and we want time taken t such as this is 10. So that will be what? If I integrate it, it will be 2t square minus t equals to 10. Why is 2t square minus t minus 10? All this will be 2t square minus 5t plus 4t minus 10, or it is t 2t minus 5, so it is t plus 2 or t is 5 by 2, so 2.5 second, right? That's one way. The other way, if you don't want to go into that relative velocity, what you can do is, I want the time t when A reaches B. So if I work in S frame only, that's alternative way I am telling you. That will be easier for you to understand. In fact, in S frame, suppose after t time A overtakes B. A and B meet each other after t time. So during that t time, what is the distance traveled by what is the distance of this A? What is the distance traveled by B? Distance traveled by B would be 1t, right? 1 into t is going to be a distance traveled by B. And what will be distance traveled by A? The distance traveled by A will be 1t plus 10. This will be 1t. In order to catch B, A has to travel additional distance of 10 meter. And you know, in S, it is moving with constant acceleration. So acceleration, the distance traveled is going to be 1 by ut plus half at square. U is 0. So this is half into A is 4 into t square. 1t plus 10, or that will give you what? That will give you 2t square t equal to 0. That is same equation, right? So you can do this way. Get your point. You have to visualize the things. Okay, let's move to next question. Yeah. An open lift is moving upward with velocity of 10 meter per second. It has an upward acceleration of 2 meter per second square. A ball is projected upward with velocity at 20 meter per second with respect to relative to the ground. Okay. Ball is projected with a velocity of 20 meter per second with respect to ground. Find the time taken when ball again meets the lift. See, the lift begins motion with initial velocity of 10 meter per second and acceleration is 2 meter per second. Suppose we have a lift over here. This is a lift. It starts its motion with 2 meter per second and 10 meter per second. And the acceleration is 2 meter per second square, and simultaneously a ball is also projected with 20 meter per second. The question is when this ball is going to meet the lift. So suppose ball after time t. So at that time t, the height of ball and height of this lift will be same. So height of lift is going to be what? Ut plus half at square, and height of ball is going to be ut minus half gt square. A is the acceleration of lift, and since ball is under free fall, so acceleration should be minus g. So u is 10 and a is 2 into t square, right? And here u is 20, half into 10 into t square. So this will cancel out. So 5. So what you have is 5 6t square minus 10t, or t will be 0. So the ball and lift are together, t equal to 0 of course, and 5 by 3 second. So after 5 by 3 second, ball and lift will be together, right? Ball and lift will be together, and displacement will be, just put this t in any one of the equation, that will give you displacement. So put it in any of the equation. Say I put it over here. So u is 20 into and 25 by 9. So that will be what? 100 by 3. This will be 125 by 9. So that will be what? 300 by 9. So 300 minus 125 is 175 by 9 watt meter, right? That will be displacement. And the question says distance traveled by ball up till that extent. See, distance may not be equal to this displacement, may be also equal, may not be equal also. That will depend whether ball meets the lift in its upward journey or ball meets the lift in its downward journey. If ball meets the lift in upward journey after 5 by 3 seconds, then distance and displacement will be same. But if ball meets the lift in downward journey, then distance and displacement will be different. Okay, in that case, distance will be this plus this. But if ball meets the lift in upward journey, then this distance is same as displacement. So to check this, we must find out what will be the time taken by ball to reach the maximum height. See, the ball will reach a maximum height when the velocity of the ball will become 0. V is u minus gt. Let's find when it becomes 0. That will be u by g, that is 20 by 10, 2 seconds. But ball meets the lift in 5 by 3 seconds only. That means it meets the lift in upward journey before reaching the highest point. See, it reaches highest point in 2 seconds, but ball meets the lift in 5 by 3 seconds only, which is less than 2. That means ball is meeting the lift in upward journey. So I can say it doesn't reach maximum height. It meets the lift before reaching maximum height. So it meets the lift in upward journey and not in the downward journey. So in upward journey, the distance and displacement is going to be same, right? So displacement and distance is going to be same, that is equal to 175 by 9. Alright, see this question. Two ships A and B are 10 km apart on a line running south to north, and ship A further north is streaming west at 20 km per hour and ship B is streaming north at 20 km per hour. What is their distance of closest approach and how long do they take to reach it? Again, I will draw the coordinate system. So A is on the north as moving west 20 km per hour, and B is going north at 20 km per hour. All right. So after time t, if this is x and y coordinate, initially this was what? 0, 10 km upward, and x coordinate was 0. So after time t, what is the coordinate of A? Coordinate of A will be what? The x coordinate will be how much? X coordinate will be minus 20t, to move by distance of 20t, and y coordinate will remain 10, and coordinate of B would be what? The x coordinate will remain 0 and the y coordinate will be 20t. So what is distance between A and B? We'll use the distance formula, that is x2 minus x1 whole square one by 2. That's the distance formula. So that will give you x2 minus x1 whole square is going to be 400t square, and here you have 10 minus 20t whole square, that is going to be distance square. So that will give me what? 20t square, and 10 I can get a common, so that will be 1 minus 2t square, and this is going to give me, okay, 400t square, 100, 1 plus 4t square, 4t. This is 400t square, 400 becomes 800t square, 800t square minus 400t plus 100, and I want the time at which this is minimum. So what you can do is, in order to decide at what time it is minimum, derivative of this and see when it is coming to 0. That's the method of calculus, and this will come at, see, 1600t minus 400. So this is equal to 0 at t equals to 0.25 second. And to be very sure, you can find the second derivative, and you'll find it is going to be 16, which is greater than 0. This point corresponds to minima. Basically, I am using the concept of calculus. See, in calculus, if you want to get the value of x for which f is maximum or minimum, for what value of x f is maximum or minimum, for that what you do is, you take the derivative of f and equate to 0. Then you solve this, then you will get some value of x, x1, x2, x3, xn. You just take derivative and equate to 0. So you get the points where the first derivative is 0. So these points may be the point of maxima or minima. At these points the function can reach maximum value, the function can reach minimum value also. So how will you check it? You can check it by taking second derivative of f and the value of x for which this is positive. At those value of x1, x2, xn, the function will be having minimum, and the value of x for which this second derivative is less than 0, for those value of x, this function will be having maximum. So what I have done is, this is a function ft, and I want the value of t for which this is minimum. So what I did was, I took the first derivative, equated to 0. I got this value. Then in order to check whether this is time of maxima or minima, I took the second derivative, and I got 1600, which is greater than 0. So that means this corresponds to minima. If it is greater than 0, it corresponds to minima. So there are slight applications of calculus which you will learn in due course, but this is what we require. So it's going to, the distance is going to become minimum at this time, right? And at this time, what's the distance? You can just put this value. You put t goes to 0.25, so that will be what? 400 1 by 16 and 10, 0.25 whole square. That will give you what? 100 by 4, 25 plus 25, 50. So D is 5.2 meter. Kilometer, sorry. The unit we have been using is kilometer. That's going to be the D min, minimum distance. Alright. Okay. Let's go to next question. Question. A boat which has a speed of 5 km per hour in still water crosses a river of width 1 km along the shortest path in 15 minutes. The velocity of river water in km per hour is. See, whenever a boat moves in river, it will always inherit the motion of the river. That is very important, and that is the only important thing in this kind of problem. Boat always inherit the motion of a river. I have seen many people making this question very complicated. and they regard it as a separate class of problem, but I don't go for that. It's a simple problem of relative velocity. You have to keep in mind few things only, no formula. In physics, the number of formulas are very less. In mechanics, you have only 3 things, and they are Newton's 3 laws. That's the only thing which you have in physics. In mechanics, you don't have any other formula. I won't give you any formula for any problem. The only formula I will be using is Newton's laws in this whole mechanics. So don't remember any formula, just try to understand the problem. This is the river. Again, read the question. A boat which has a speed of 5 km per hour in still water. In still water, when water is at rest, the velocity of boat is 5 km per hour. Crosses the river of width 1 km. The width is 1 km. And I want the boat to cross the river in shortest path. Suppose here is the boat. So I want it to cross along the shortest path. So what can be shortest path? You can easily understand. This is the shortest path which boat can take. This is the shortest path. Velocity of river water in km per hour is, I want it to cross along the shortest path in 15 minutes. So the net velocity of the boat, see, velocity of the boat is going to be velocity of boat in still water, say call it Vs, and velocity of river. See, velocity of river will always get superimposed on the velocity of the boat. So velocity of boat is 5 km per hour. So that velocity and velocity of river which the boat will always inherit. Velocity boat will always inherit the when boat is not running, the engine of boat is off, then also velocity of boat is equal to velocity of river. When engine of boat is running, then you will have additional velocity, that is velocity of the boat and velocity of river will get added together. See, velocity of river will always get superimposed on velocity of the boat. Velocity of river, boat will always inherit the velocity of river. So even if you don't operate the boat, then also it will be moving with velocity of river. And when you are operating the boat and that operating boat gives it a velocity of Vs, the net velocity of boat is going to be Vs plus Vr. S stands for still water. Vs is the velocity of boat in still water. That is the contribution of the motor that you have in the boat, right? Okay. So but I want boat to move along this path. So the net velocity of the boat should be in this direction. Net velocity of the boat should be in this direction. And what is Vr? Vr is velocity of river which boat will always inherit. So the velocity of boat, its own velocity, should be in this direction. That should be velocity of boat in still water. This velocity superimposed with velocity of the river should give you the net velocity of the boat, and that should lie in the direction of shortest path. You understand this problem? The net resultant velocity of boat should be perpendicular to the bank. Only then it will be crossing the river in shortest path. And velocity of river is this. Velocity of river is this along the bank. So the velocity of boat, its own velocity should be in this direction, which superimposed on Vr should give you net velocity of boat in this direction, right? So suppose this is theta, and we have this idea. What is the velocity of boat? That should be equal to the width of river is how much? 1 kilometer, and we should cross the river in 15 minutes. That is 1/4 hour. That is 4 km per hour. That's the velocity of boat, and velocity of river is how much? That is something which we have to find. Velocity of boat in still water is 5 km per hour. That means this theta, if I take a right angle triangle, I got this velocity which is 4 km per hour, this velocity is 5 km per hour. So cos theta is 4 upon 5. So what is the velocity of river? That should be equal to velocity of boat into sine theta. So you got the hypotenuse, you want the perpendicular, you got the base also. Base by hypotenuse is cos theta. So this should be equal to velocity of boat in still water into sine theta, and velocity of boat in still water is 5. And sine theta will be what? If cos theta is 4 by 5, the simple geometry says sine theta is 3 by 5. That would be 3 km per hour. That would be the answer. That would be your answer. Now let's look at this question. A river is flowing from west to east. Suppose you have a river. Oh, sorry. Suppose this is the river. Suppose this is the river. A river is flowing from west to east. West to east. This is the velocity of river. 5 meter per minute. A man on the south bank of a river. Here is the man. M. Capable of swimming at the rate of 10 meter per minute in still water. So again, when man will swim, he can swim at 10 meter per minute. But his net velocity will be 10 meter per minute plus velocity of the stream which he is going to inherit. Everything in river is going to inherit the velocity of river. So the net velocity of man would be the velocity of man in still water, let's call it Vs, plus velocity of river. And velocity of river is fixed. This is 5 meter per minute. Want to swim across the river in shortest time. See, wherever man is, then he is going to inherit the velocity of stream VR. He is going to inherit the velocity of the river, which is say it is VR, which is 5 meter per minute. He is going to inherit this velocity. Now see, condition is I want him to cross the river in shortest time. See, the man is going to inherit this motion of river, but this motion of river which he is going to inherit will not contribute anything to the motion in this direction. See, in crossing the river, which motion is important? Motion which is in this direction. You have, see, if I draw a coordinate system x and y over here, then whatever motion you have along y, that is going to contribute in crossing the river. The motion which you have in x direction, that is not going to contribute in crossing the river. So motion in y direction, if velocity of the man is say Vx I cap, plus Vy j cap, then this Vx component will not contribute into motion in y direction. It's only Vy component which is going to contribute in the motion in y direction. Getting a point? The motion of man can be split into motion in x direction plus motion in y direction. So it's only Vy which is going to contribute, and this river velocity which is going to inherit will not contribute to Vy. So in order to cross the river in shortest time, we want this Vy to be highest. We want Vy to be highest, and this velocity is completely in x direction. It doesn't have any velocity in y direction. This is having no Vy component. This will have a Vy component, and I want Vy to be highest. So Vy component will be highest only when this Vs completely lie in y direction. So this will not have any Vy component for sure. all the VR is in X direction, and in order to swim in least time, this Vy has to be highest, because only motion Y direction is going to contribute in crossing the river. The motion in X direction is not going to contribute in crossing the river, and we are seeing that VR is lying in X direction, so it has got no contribution in Vy. So in order to have maximum Vy, that will be possible only when Vs completely lie in Y direction. Vy will be maximum. This we can't change. We don't have any control over this. River velocity will always be in X direction, and that has got no contribution in motion Y direction. So motion in Y direction will be speedy. It will be the man will be able to travel across the river in shortest time only when Vy is highest. And in order to make this highest, that will be possible only when Vs completely lie in Y direction. Vs completely lie in Y direction. So Vs should be, Vs means motion of velocity of man in still water, its own velocity. Vs should be equal to 5 j cap. So man should swim in this direction, though he will go like this, but his own velocity should be in this direction, right? His own velocity should be in this direction. His net velocity will be in this direction because VR will get superimposed on it, but his own velocity should be completely perpendicular to the bank. So he should go due north. That should be your answer. Okay.